So here's part two, where I approach this problem just slightly differently. And honestly, the only reason you might want to do it this way instead of the way in the first video is that you're just uncomfortable with all those fractions in that equation, and that's fine. It's kind of a way to avoid those fractions. So the idea here is to not be on a unit circle. So instead of thinking that the y-coordinate of that point on the circle is 4/5, I instead think of SOHCAHTOA and go, all right, I've got this angle, and actually for the triangle I'm really referring more to the reference angle over here, and I keep track of the signs, the positive and negativeness of things by knowing them in the second quadrant. But you know, here's this angle. Here's this angle where the sine, the opposite over the hypotenuse, the sine of the angle is 4/5. Now I can solve for this missing piece by just going 4 squared plus a squared equals 5 squared. So 16 plus a squared equals 25. Subtract 16 from both sides. A squared is 9. A is, and again, plus or minus 3. And then I think, oh, wait a minute, you know, I'm in the second quadrant, so yes, that size is 3, but the coordinate is -3. The x-coordinate is -3. So I go, okay, so cosine is going to be adjacent over hypotenuse, and so it's -3/5. And if you remember from the first video, that's the same thing we got. And the rest of it, going tangent is sine over cosine, secant is 1 over cosine, all of that's the same. You're just getting this ratio and blowing up your circle to have a radius 5 instead of 1, so that in this equation solving you can avoid having fractions.